Students, in this video we're going to be looking at how to integrate through linear partial fractions. So the idea with this is we've got situations where there's a quotient going on, and when we try to divide it out, it gets really messy. And yeah, basically that's kind of the situation. And you can try using U substitution. You can try seeing if there's an easy way to break things up. But basically you get into a situation where, hey, like dividing x into x squared minus 5x minus plus 6, like if you actually went through if you tried to set up and be like, I'm going to divide and see what happens. Well, as soon as you do this, you're like, whoa, how am I supposed to, but what am I multiplying here to make x this? And then you're going to end up multiplying by like square roots and stuff. Like it's going to get messy, and it's not guaranteed to be very efficient. So our other option is to actually see if we can break it up into basically a bunch of linear fractions. What we mean by that is basically just a fraction that's like something over ax plus b, and then another thing that's, let me pick some new variables here, c over dx plus q or whatever. Basically, you're looking to be putting things over like a slope-intercept sort of form there, because when you integrate just a basic linear situation there, you're going to just end up with ln. So let's dive right in and see how we can make this work. So clearly I've got a situation here where all the tools that I know up till now aren't going to work. So the next approach is to see if I can break this up. And in order to be able to break it up, I have to be able to factor it if it's not already factored for me. So I'll take a beat and I'll do that. X over dx, and then x minus 3 and x minus 2. And sometimes when you do this, actually stuff can simplify and you'll be able to integrate it just right off the bat like that. But again, we're not in a situation like that. The next thing I need to do is to recognize that, hey, this can be rewritten. I'm going to do some pre-calculus work over here. I'm going to view this quotient as the sum of two fractions, okay? Because if I have a fraction that's x over x minus 3, x minus 2, then there must be two other fractions that I can add where I have a over x minus 3 plus b over x minus 2, which would yield this bad boy right here, okay? So I have some situation, or I'm going to create a situation where I'm basically looking for the values for a and b that make this true, right? And like you can think about this. I guess if you need help with fractions, you should come find me in class. But this is how we set these questions up. So the next thing I'm going to do is actually just kind of solve this through. And so first off, I want to get rid of all these things in my denominators. So I'm just going to multiply everything by x minus 3, x minus 2, kind of missing a negative there. And when I do that, everything cancels out here on the left side. The x minus 3 would cancel out with this a, but I'd still have that x minus 2. And the b's x minus 2 would cancel out, but I'd still have b x minus 3. And then I kind of get to this weird point where it's like, okay, what do I do at this point? And so at this point, we can actually just start picking values for x, okay? And there are a couple of values that are going to make our lives easier, right? Because this equation, the way this is set up is we're saying this is true for all values of x. And so what I'm going to do then is I'm going to pick a value for x that's going to make my life easier. I'm not going to pick 10 or 20 or 30 because I still would have two variables kicking around. But if I pick something like 2, then all of a sudden 2 minus 2 gives me 0, and I have an a term completely cancel out, and I'm just left with one variable. So let's do this through. I say, hey, x is equal to 2. And if that's true, then I'm going to have 2 is equal to a, 2 minus 2, plus b, 2 minus 3. This a term is going to cancel out because a times 0 is 0. And then I'd be left with 2 is equal to b onto negative 1, or negative 2 is equal to b. And then once I know what b is equal to, well, then I can just come over here and I can substitute in, and I can say, and again, I would probably pick another, so you can either substitute in, or you can also just, you know, do the same thing again for b. You can pick negative 3. Let's pick 3 there. So let's say I say x is equal to 3, just to kind of get some practice with that, because I know that's kind of a novel thing for us to have two variables and all of a sudden replace everything with some other value. So as x is equal to 3, and then I'll say 3 is equal to a onto 3 minus 2 plus b onto 3 minus 3. This cancels, so I'm going to left with 3 is equal to a 3 minus 2 is 1, or That's just equal to a. So if I come over here, I can rewrite this then as the integral of a over x minus 3, but I know my a now is 3. Nope, in this case it actually didn't end up being 3 just because that was the minus 2 there. So it ends up being 3 over, what did I say, x minus 3 dx, plus the integral of negative 2 over x minus 2 dx. And now what I can do is I can actually take that 3 and that negative 2 out completely, and I can say, hey, that's going to be 3, the integral of 1 over x minus 3 dx, plus negative 2, actually just do the whole thing, just minus 2, integral of 1 over x minus 2 dx. Now sometimes you might want to use u substitution here if you had a trickier, if you had a coefficient, you're having a little bit of trouble seeing how that would cancel out with chain rule or whatever. But this is going to be pretty straightforward, so I'm going to have 3 natural logarithm of x minus 3 minus 2 natural logarithm of x minus 2, and then I'll tack on a plus c there. Let's do another one right here where it's already factored for us, so this is nice and easy. So I'll say 1 over x minus 2, x minus 1 is equal to a over x minus 2 plus b over x minus 1. And I'll multiply by everything, so I get 1 is equal to a onto x minus 1 plus b onto x minus 2. Then again, then I'm going to pick values that help me out. So I'll say x is equal to 1, and I'll do a little thing over here where I say x is equal to 2. And so I'll say 1 is equal to a times 1 minus 1. That's going to cancel. Plus b, 1 minus 2. So it'll be 1 is equal to, 1 minus 2 is going to give me negative 1. So negative b is equal to 1, or negative 1 is equal to b. Then I'll do the same thing over here where I say 2, nope, just kidding. 1 is equal to a times 2 minus 1 plus b onto 2 minus 2, which means this will cancel. And so I'll have 1 is equal to a onto 1, or 1 is equal to a. So I can rewrite this then as the integral of 1 over x minus 2 dx plus the integral of negative 1 over x minus 1 dx. And again, this is just going to be ln of x minus 2 minus ln of x minus 1 and a plus c. Now, I set up all these things with repeating fractions, and as a fun little aside, I couldn't find any AP questions that included them, so I'm going to skip this in the video, and if I find some, then I'll cycle back and we'll do a video and a little lesson on them. But I think they just do the more basic linear factors with no repeating factors. So that's it for this video, and I'll see you guys in the next one.